Hi there, this is exercise 4D then. It builds on what we looked at last time, which was the sequences review from work we did earlier in the year. And now I'm going to include some other aspects of sequences that I know we're going to need. So before we get started, a reminder, and this is the formula we used last time. This is the nth term formula. The A, remember, is the first term, and the D is the common difference. So this is for arithmetic sequences today. We're only looking today at arithmetic sequences. They're the ones that go up by a set amount each time, or go down a set amount each time. So a little starter for you, have a look at that question. Maybe pause the video and look at it. You should be able to do that. I suppose the slightly weird one is the bottom one. And the bottom one talks about the sum of the first 10 terms. That's where you work out the 10 first terms and you add them all together. See if you can do that. So I'll let you do that, and here are the answers for when you've done it. So there are the answers, and you should have got 120 for the sum of the first 10 terms. So as I said, you know the first one's got 3 and the second one's got 5 and the third one's got 7. And I suppose if you kept adding up, you really add up the odd numbers, aren't they? Or not all the odd numbers, but you keep adding them up. And I'm guessing the last one of the first first 10 terms is 21. And apparently if you add all those up, you get up to 120. And I suppose it's that working out the sum that I want to concentrate on today, making sure you understand that. So these are the formulas that we can use for arithmetic sequences to work out the sum of the first 10 terms, for instance. So in that last example, what do we have? We had 3, 5, 7, and it went all the way up to 21. They were the first 10 terms. Is that right? 21. Let me just go back and check. The formula was I think that's right. Yes, I think that's right. It goes up to 21. And so if you therefore do this, the sum of the first 10 terms, and we can use either of these two formulas. I'm going to use this formula here. One way of doing it is if you know the first term and you know the last term, you can add them together. So I'll do 3 plus the 21. And you times by then n over 2. In this case it's 10 over 2, which is obviously 5 times the 24, which is 120. That's what the answer said just now. Now the second way of doing it, and it's equally good and probably more useful actually this way. So if you don't necessarily know what the last term is, you can use this instead, and it says n over 2, which is still 10 over 2. And this time we do 2a. Now a was 3, so 2 of that is 6. Plus n minus 1, well n is 10, so n minus 1 is 9. Times the common difference, and I think they went up in 2s, yes they did. So if you do this instead, 10 over 2 is 5 times by 6 plus, well obviously you do the bottomless first, so the multiplication first, that's 18 plus 6 is 24. Oh, it's the same answer then in that case, so it's 120. And you can see it worked both ways. So we've got these two new formulae. One that defines the sum of n terms in terms of the common difference, an a, and obviously n, and the other one that defines it in terms of the first and the last terms, the a plus the l, and obviously the n. So let's use those to now do a few examples. The common difference of an arithmetic series is d equals minus 3. Now I did say to you last time that I would tell you the difference between a sequence and a series. Now is a good time to do it. A sequence then is where you write the terms of a sequence. It might be 5, 7, 9, 11, ... And notice I put a comma in between each one. Whereas a series is where you add up as you go along. So it says maybe 5 plus 7 plus 9 plus 11 plus So do you know what? In most cases no one cares. They're broadly the same, and I wouldn't worry about the difference. But that's what technically it's meant to be. So anyway, we'll go back to this question. We've got the common difference is minus 3, and the sum, it says, of the first 30 terms. So I use a capital S, 30. Now what is the formula I'm going to use? I want the first term, and I think I'm going to use this because I know the D, I know the N, and I think I'll be able to find the A if I use this formula. So I'm going to use this. It says 30 is the number of terms, so it's 30 over 2, and the formula then says 2A plus n minus 1. Again, personally I never write n minus 1, I just go, oh, it's 30, therefore it's 29, times the D, which is minus 3. And it tells me what the answer is. It says the sum is 255. So I think it's just a case of working this out. So this is 15 when I do it. So 15 times 2A is 30A. And this is minus 87. So obviously I've got to do the minus 87 times by the 15, and that's 1305. It's a negative, so minus 1305 equals 255. And I could have got rid of the brackets in a slightly different way, but it makes no odds. Now if I add that on by moving it over to the other side, I obviously get 1560, so I get 30A equals 1560. And if I divide that by 30, I get the first term, according to me, is 52. So it's not a common answer. The answer says 52. There you go. So just using the equations. So I'll try to do the same on each of these. The first term of an AP, notice this is an abbreviation for arithmetic progression. And I talked just now about the fact that sometimes it's called sequences and sometimes it's called series. I would say an arithmetic progression is an easy way to say it could be a series or a sequence. So I wouldn't, again, it's just a third way of saying the same thing. So I wouldn't worry about that at all. The first term anyway, it says is 20. And the sum of the first 16 terms, so again, S16. And it reckons it's 280. So I'm going to go over here. What's it after? What's the last term? Oh, right. Now, the last term and the common difference, I suppose I could use, last term, might as well use that, mightn't I? So using that formula, the sum of 16, so it's 16 over 2, 20, plus the last term, little l, equals, and what was it equal to? 280. So I did say there were different ways of doing this. I'll show you this now. You could move the 8 over and just divide. So if I move the 8 over, I get 20 plus L equals, and I've got to do 280 divided by 8. And it says 35. And you can clearly see then that L is 15. So that's that one done. What else do I want? I want the common difference. So, well, probably easier. I know the last term is 15. Let's use this formula here. This is the last term. So my last term, my UN, if you like, is A plus N minus 1D. That's my formula. And let's chuck some things. My last term I know is 15. My A was 20 plus N minus 1. There were 16 terms there, so I can write 15D. And I can effectively call this the last term, and that will tell me what the common difference must have been. So anyway, move that over, I get minus 5 equals 15D, and you can quickly see that D is minus a third if you do that division. 15 and minus a third, there you are. The fourth term of an arithmetic sequence is 36. So again, I'm going to write U4. And what is U4? Well, again, using this formula, it's A plus N minus 1D. So here it's A plus 3D. And that equals 36. And the sum of the first 20 terms, equals 590. Now I've got A and D in this. I think this is similar to Taylor's equations question, so I'm going to stick with this formula here, because it's got an A and a D in it. So what have I got? It's n over 2, n is 20, so 20 over 2, I had no problem if you just write 10 straight away. 2a plus n minus 1, again, n is 20, so I'll write 19, d equals, what did it say? It's 590. So, tidy that up a bit. Therefore, well, I've got two equations effectively. I've got a plus 3d equals 36. I don't need to change that at all. Not yet anyway. And what's this? I've got that's equal to 10. So if I'm going to move that on the other side and divide by that 10. And I reckon I'll get 2a plus 19d equals 59. I'll just move the 10 over. Times the top equation by 2. I'll get 2a plus 6d equals 72. Just me being a bit lazy. And what we're going to do, I'm going to subtract going downwards. That will disappear. 60, I'll get minus 13d equals, and that looks like 13 to me, so d must equal minus 1. And if d is minus 1, I can come back over to here, chuck it in here. A plus minus 3 equals 36. I reckon a is 39. Perfect. So it just works out quite nicely, and very often this just comes down to simultaneous equations. Find the sum of all the multiples of 3. Of course, the multiples of 3 go 3, 6, 9, upwards. But this says between 100 and 103. And I suppose I need to know that 333s are 99. So my first number between 100 and 1000 is 102. It goes up, it goes up, it goes up. And my last one must be 999, thinking about it. Because obviously 3 times 333 is 999. So I've got my first term and I've got my last term. Do I know how many terms there are? Oh, that's a question. Because I will need to know that. If I'm going to use that, it might be, I definitely need to know it, I think. So, how many terms will there be? There's a question. So I was just thinking about that. So I reckon the way to do that is we know there are 333 lots of 3 equals 999. But I've lost the first 33 of them because it doesn't start to 100. So 333 minus 333, I reckon I get n equals 300. With any luck, I've worked that out right. So therefore my sum to the first 300 terms of this sequence is 300 over 2. A is 102 plus 999. So let's have a go at that. So we've got 102 plus 999 equals, and I'm times it effectively by 150. And I get a rather large number, which you expect it to be large, I suppose, 165150. What did I get last time I did this sum? Good, sum is the same. This one uses the summation notation that we've seen in the past. We saw this earlier in year 12. I haven't seen it much since, but basically it means add up all the numbers from 1, going up from 1 to 10. So if I just write these numbers out, when n is 1, I get 4, minus 10 is minus 6. When n is 2, I get 4 2s are 8 minus, that's minus 2. So I'm doing that, and each time it's going up. So I've got an a of minus 6, I've got a d of going up in 4s, and I've got an n of 10. So the sum to the first 10 terms must be, I'm going to use this formula here. So it's n over 2, 2a minus 12, plus n minus 1 is 9 times goes up in 4s. So it's 5 lots of 36 for this, minus the 24, minus the 12 is 24. I reckon 120. See what I got last time. 120 is right. Okay, so looks like I did it slightly differently last time. Anyway, so that's the exercise. Based on that, you'll notice there's a lot of simultaneous equations which you solve. There's a lot of using one equation to get one letter and then you sub it in the other, and it should be fairly straightforward. So have a go at that. I don't know what's wrong with question 2b, but apparently miss it out and see if that's okay for you. Best of luck.